welcome everyone. That's today this workshop actually is supposed to be handled in a different way. And unfortunately, the original presenter, we have discussed with them, they couldn't join us. And then we tried to find alternative, and we were just unlucky to not having a real developer or the person who has developed one of the open source softwares for FLIM analysis today in this workshop. So that's why we decided that's just showcasing one or two of these available ones, the plugins, softwares, whatever is available to analyze the FLIM data. So I'm just showcasing the ones that I have a little bit experience with that, and naming one or two, which I think that they have great potentials, as well as offering a lot of the possibilities for different level of the FLIM analysis. So just by naming them, I'm going to open the web page of them. So one of them is a member of the global software. It's called Global for Images, CMFCS. It's from Enrico Craton's lab. And they have been developing this software so quite a time, and the last version I think is SimFCS 5, but or 4, and this one is now available for free. So I think that's before, not thinking, I knew that before it was paid software, but as far as tried it on my PC, so I would try to change the screen sharing. So I show you that how does that look like. Not talking about that today because, to be honest, I don't have experience with the software, and I would love to start to know that and how does that work. So shortly going to the other screen, stopping that, and then come here. So here is how it look like when you, the chat can go away. When you're just double clicking on the software, this is what you see. So as you see that they can do several kind of analysis with that. And so this raster imaging correlation spectroscopy, the FLIM, and SimFCS, which is, if I'm not wrong, it's doing microscopic images analysis, as well as that's with some focus on fluorescence correlation spectroscopy. But as I said, I'm not really expert on that. I don't have experience with it. I just played around with this software, and that's it. So when you click on the FLIM, you see that's just maximize that, and that's the first thing which comes, you know, just to my mind, that it would have been nice if we could just maximize that and everything gets a little bit larger. It's quite difficult to read all the information which is here. But what is great about that is that the people behind this one, Enrico Craton and his lab, they have years and even I can say decades of experience in this field. And there is a lot that one can do with this software. And unfortunately, I don't know how to start, how to really present it. Just tell you that this is available and they have made it free. I think that's something like 7-8 months. And just stop it. If there is anybody from that group, I would be happy to comment on that. So today that during our workshop. And if not, then going to the other softwares. So another one is FLIM Fits. I think that's one of the most famous one. And that might be one of the old ones which are still available. So this software has been developed by Sean Warren and the others so in 2013. And it still is functioning. It's functioning very well. It's based on MATLAB. And so it's been a while that you can analyze the data on FLIM feeds in combination or in collaboration with Omero. So you can have your data on Omero.
Photo was a different.
Pardon?
Sorry.
Okay. Yeah, so you can have your data on Omero, and then just while loading your data, FLIM data, in FLIMfeed, you can just say that load the FLIM data from Omero, then you can log into your account and then access your data, and then load your FLIM data here, doing some analysis. Here it is. I have just opened an image here. This is a FLIM image, and what you see, it's an intensity of that, so no fitting has been done yet. And so this is also not the software that's today I would talk about. I'm introducing this one. That you can do so many things which are necessary and basic for FLIM analysis. But what is great about this software is that there are possibilities that you can load like 96 well plate experiments in this software. So feed the software with such amount of data, which enables us to do high throughput FLIM analysis. That's a great thing. And also that's the top of that, it gives us some other possibilities that's usually that in the open source softwares are missing. One of them is the correlation curves. It's not what I'm going to do is not really greatest way of analysis. I just want to showcase that how does that look like very fast. So this is a decay curve of a pixel, and if I assume that's a 2 exponential decay, I can estimate. So that's one of the possibilities that we can estimate the. Okay, not this one. I clicked the wrong. In the tools, we can estimate the IRF from the data that we have measured. So it's trying to minimize and adjusting to find the optimal chi-square with an iterative way to find out what is the IRF and calculating IRF back from your measured data. And when you do that, you can save this one and reuse it later for any other analysis that you want to do. And if I just load this IRF and go into the IRF, so it's loading that here. So this is the dirty fitting. I just want to have some images to look at the other parts. This is not going to give me really good fits. There are so many other things in between that has to be taken care of. That the good thing here is that when you go to their websites, you can go through the video tutorials. There are few, but very informative. What you find in these 7 videos, it's quite enough for anybody to start. And another one is the documentation, which is I learned a lot from that. Not only that how to work with FLIM feeds, but in general about FLIM itself. Unfortunately, this software doesn't have any active support, and the developers are not supporting that, I guess, actively. I can say that. And but if you have any question, you can use the image.sc forum. So like many other questions, bioimaging questions that we can ask in that forum, so also that we can ask the questions regarding FLIM feed there. I'm sure there are people with a lot of experience there, even sometimes developers that would respond to the questions that we have. Anyhow, so here that in the correlation, we can say, for instance, if I look at the correlation of the lifetime 1 and the intensity, then in the linear way, so the distribution of this one, if I have some kind of autofluorescence or background that would just be drifted toward the short lifetime, as is happening here, and that's because I have some varying backgrounds in this image. But this can be corrected and so on. As I said, that there are 2 things which are very important. First of all, it's having handshake, and also you can load your data directly from Omero. And the other thing is that's if you have in mind to do high throughput FLIM data analysis, there are templates and platforms ready on this software to do your analysis. But unfortunately, this software is discontinued. Yes, I guess so. I can use that word. So it wasn't ever a financial reason to develop that one. So it's been always free as far as I know, but there would be no new version and there is no active support on that. Okay, so passing these two, there are two more that's I have a little bit experience with them. One of them is called Slim Curve. That's a plugin on ImageJ. So I've been using that one quite sometimes just to double check. So the point here is in the facility, when we buy a system, usually that it comes with the software for the acquisition and analysis, and we have almost always the licenses to analyzing the data that we acquire from the microscopes or the specific techniques. So the need for an open source software to analyze the data, it's not really our first priority in the facilities, but time to time, it was happening that for some data, it was necessary to look on an alternative, and that's how I learned about these ones. So one of them is a Slim Curve plugin. I really liked it. That's an old version, and it's based on the FLIM library and as well as the time resolved imaging. I just come back to the chat, so I see that there are some chats here. Ooh, wow, so many. And yeah, so we talk about that. So the point here is that this plugin is also kind of discontinued, and there is a new version of that, or there is a plugin that has been introduced this year. Here, that's a bioRxiv publication or the preview of it's called FLIM-J. It's an open source ImageJ toolkit for lifetime data analysis. That's a kind of a new version of a Slim Curve, or that's a plugin which is developed based on Slim Curve. And we talk about these two today. So I just go back to the chat to see that if there is any question. Stefan, Thomas, Steffi, was there any question that I was missing? If we can just
mostly about being able to read files or not, but the chat it's more discussion than questions, I would say.
Yeah, it's about the Umero, Ali, because at the moment you cannot easily load the files to Umero.
Okay, great.
But they know, PicoQuant knows, and also the OME team knows. So maybe now, after establishing a new community, there will be more pressure on them to solve it.
Yes. So we reached to this point. Some point that needs some pressure. What actually, that was a good discussion. I just missed it. And are the tools limited to time domain data except globals, which can take our camera data as well? Gerhard, as far as I know, that these three, at least I have never seen any frequency domain analysis on them. I would say no. They are designed for time domain or TCSBC data to read and also to analyze them. Elena, I don't know what is .msr. So what you're saying, that's specific company extension for the file?
Yeah, so basically it's from an acquisition software that's called Inspector. That's what we have, and it gives you .msr files. And every single time, I think they update ImageJ, which is very frequently, the ability to import .msr files breaks down.
I see.
So it's basically a bug, and most of the time, basically, like 90% of the time, you can't import MSR files.
Would that be possible for you to convert them? So to bin file, or I don't know, some like more familiar files extensions which are used that in the, or even ASCII. So that's different model that you can convert the lifetime data.
You can, but the thing is, like, you shouldn't have to. You can, in the inspector acquisition software, you can do some kind of batch conversion, but
Okay.
yeah, it's a bit annoying.
Yeah, that's true, but in some points it is necessary. So when I talk about that, we see that these softwares, they have some limitations, but the good thing is that the FLIM feed and CMFCS, so FLIM feed for sure, that can read most of the I would say that it can read SCD files from Becker and Hickel. It can read the PTU files or PT3. I'm not sure. That's one of these two from PicoQuant, as well as the file extension from Navision. Make sure.
I can crank it up here.
I think that's, yes, that would be Navision. Control F, and that's how usually I solve problems when I don't know with the image analysis. And search for some words that I know that I might find the information. Yes, it's Navision. So can read so many of the formats as well. So other also, that's when you convert them to the bean or ASCII, so it can be loaded as far as I remember on FLIM feed. And also that's there are some tutorials for the CMFCS as well, that's explaining. So because easily you can load the data from Becker and Hickel, so the SCD files. Yes, I think SCD files, and also that there are tutorials about importing PicoQuant file extension to CMFCS software, so the global for images as well. But Slim Curve, as far as I know, that you can use it for the SDD file. So you need to convert your files to SDD, which is Becker and Hickel extension. Okay, so Liat is saying that I found even when converting with ASCII, you still have to edit the actual text inside before it can be opened. Yeah, so that's another point regarding that's when we are having open source software, so it's a matter that there isn't really a consistent team usually behind developing that, and usually that's they write the code. So master students, PhD students, or postdocs, they are like they have a project and the time to work on that, and they need a tool. Sometimes they need to develop a tool to solve their problem, and those tools not always global enough, universal enough. That's answer all the questions. So when you need to adjust, for example, the header or something in the ASCII files that would be fitting for many open source softwares, that is coming from this non-consistency that in the development team, and also that's the time line of the development of any software. So I would just go on to showcase, starting with the Slim Curve plugin.
Maybe make one comment toward that. I want to third nice comment. If the situation is like that, like you have a postdoc developing a program, you don't have software, you have people. And usually whenever that person changes to a different lab, the software is dead, which is exactly the problem with lots of those tools out there. Open source or not, developed by some labs, if it's not included into some bigger programs, such as ImageJ or Cell Profiler or something, it just get lost, and after a few years, nobody can use it anymore, and development will start over again.
Exactly. So that is most of the time that's what's happening. And if there would be enough time for a group of people that they are working together as a team to develop something that we can use it for years, but it is needed. I think that's there has been a discussion also that's in the bio image processing and also bioimaging community. That's a very serious discussion to support the teams or the people, that's small or large teams that they are developing open source softwares, to maintain them for years. It's just not going to be faded away when that person is going. So that would be like a project line which is receiving consistent support. So that's the matter of funding, that's the matter of how the groups are handled and so on. So I think that's the reasons, and this discussion and this conversation is beyond the context of this workshop. And I would like to just showcase few, not really going too much in details, that might not be very helpful for everyone. Less that they are, I have to mention that this is very important discussion. So many people benefit from open source softwares in general, but we need to make sure that's it is also that's maintained over time. Okay. Yep, sure. And so here it is. It's our famous Fiji imaging. Fiji is just imaging. This is a comprehensive tool, and I am afraid if anybody would just be working with the microscopy and bioimaging and doesn't know this tool, if not, spend as much as time needed to learn about it. I'm really in love with Fiji. And one thing is that you can find so many tools in this tiny user interface. Just clicking on the plugin and you see that the list of the plugins, and these are not all available. So these are not everything you can do. That's depending on what you want to do. There are tools in Fiji, or you can ask the community, and there are people in this community that they would be happy to develop them for you. So let's start for what we need. So I start with just searching for SLIM curve, which is in the analyze, lifetime, and SLIM curve, or simply I just search. Usually that's how I do. I just search for that. And as soon as I click on that, there is a pop-up window. And this window is searching for a file which has STD. It's in all the data, but I'm going to open this data which has been acquired from Becker and Hickel. This test 2, this is, I'm using that because this is a test FLIM data, which you can find it on the FLIM-J repositories. So I would like to analyze this data with the SLIM curve and then with the FLIM-J, and then see that how does that look like and what do we have. So simply explaining what we have here. So we have 4 sections on the software. The first one is giving us a control for fitting. That's a fit window, so we can choose that if we would like to do pixel by pixel fitting, if you would like to do the fitting on single pixel, or image-wise in the whole field of view. And then different algorithms. So RLD stands for Rapid Lifetime Determination. It's something similar to Fast FLIM that we have been talking about the last 4 days. What it is and how it is working. It's like a fast determination of the lifetime per pixel, just giving us an idea. And then we have the LMA, which is the iterative fitting algorithm that we use to find out the best fitting pixel-wise or image-wise or ROI-wise. And then the function, we can choose between single, double, mono exponential, double exponential, or triple exponential, or stretch exponential, which I have never used it, and I guess that's correspond to like incomplete decay curve, when we have a high repetition, laser repetition, and the decay is not finished the time, and it's incomplete, so the fluorescence is not completely decayed, and we might use this stretch exponential. But this is what I guess. So if I'm saying that something wrong regarding that one, and nobody and anybody actually used this one and knows that, just unmute yourself and hop in and say some words about that. Also, that the noise model is that when you are recording the data, so the data is like fluctuating. It seems like there is a noise on that, and that's intrinsic of the acquisition we are doing and recording that we have, and we can just use different models of the noise to compensate that when we are doing the fitting. So maximum likelihood estimation is recommended when you don't have so many counts per pixel in your images. So we keep it like that. The fitted images, that there are so many parameters that we can choose between them. Oh, that's interesting. Where are the, oh, okay, single molecule. If I go to the double, it would be easier to see them. Just minimizing the log. Here, there are so many, so we can focus on the amplitudes and the lifetime components. This is Z is standing for the background and chi-square, so we can have images per, doing the analysis per pixel for the FLIM data that we have, and then we get all these values like an image of each of them. What I'm interested in is F and T. It's lowercase f, so there is also capital F, which stands for the fraction, intensity-based fraction, and there is lowercase f, which stands for the amplitude fraction of each component. So I would just say that what I want is the amplitude fraction and the lifetime component. So here is about the cursor. So if you look at the decay curve of the pixel, so I choose this pixel or any other pixel, and this decay curve, you see that there are the cursors, that's where we are expecting to have the IRF, and then where our decay starts, so that's the actual decay. That's a range we are going to fit our decay curve between them. And also down here in the excitation, we can use the default one. We can import something, load this. If we have measured an IRF image, we can load them from here, or we can estimate from the current X and Y, so the data that we have. So we see that on the control here. What does that mean? We can have a Gaussian one. That's also possible. So usually I just keep it alone as none, and then say estimate it. So it looks at the data and estimate the values for starting and at the end, and then somehow estimating the IRF as well. So excitation is actually just a naming, and that would be the instrument response function. So here what we have is a XY, so usually I don't change it as for the representation of the data here, and the threshold, it's automatically applying some threshold here. So, and you see that's saying that's 57 if there would be less than 57 counts per pixel. It's just assumed that it's threshold. I can just type it in 1, and this is how the image look like. And also that's maybe that I increase it by myself to find out, maybe that here 20. I would say that this is my background. The rest of that might be the signal. I would like to have it. So, and then we have the reduced chi-square or the chi-square. So this one is missing here. That's a target, and this is a value which below that would be considered as a not good fit, and it would be just discarded from the analysis and the data that we get at the end. And also that we can ask to display any mean value. You can choose between the values we have or not. And yes, so we just leave it there. And with the parameters for the fitting, so we have the amplitude, lifetime for the component 1, amplitude, the lifetime for component 2, and background, which are going they are going to be fitted now. So I can just also fix the background, for example, to 0. That as yesterday we were talking about that. We have to do some tests. I don't have data here to find out that's either to keep the background to 0 or let it fit. So I just run it as it is by default. After that, setting all of them, I can simply checking one more thing which I have missed, and that's the decay curve, number of the counts that I have per pixel. So the good thing about doing that in Fiji is that when I just hover the cursor over the image, I get the value here. So just if you look at here, see that's how many counts that I have per pixel. So it seems not enough. One thing that I can do is the binning, and that's the Becker and Hickel binning. So as far as I can say, this supposed not to change. So that's a definition of the Becker and Hickel for the lifetime binning. So it does not change the spatial resolution in your image. So it doesn't change binning actual pixels in your image with each other, but it's binning the lifetime information of the neighboring pixels together. So we are doing like a kind of smoothing in the lifetime data, but we keep the actual spatial size of the pixels as we have acquired to then later on when we overlay the lifetime data on the confocal or multi-photon intensity-based images that we have the actual intensity image that we acquire in the beginning, and we overlay them, the resolution, the spatial resolution is not dropping down drastically. But since it's going to be smoothing in the lifetime, so we are having kind of like averaging locally the lifetime. So we should be careful about that, what we choose. But 3 by 3 is that like every 9 pixels, the lifetime information every 9 pixels would just be assumed or accumulated to 1 pixel, which is at the center of that. So I just keep it like this, and you see that the decay curve looks more familiar to us. And now I can estimate the cursors again. So if that will change anything, but that's quite okay. Also, that's should be possible to manually adjust them if you think that would be necessary. But we estimate them as they're supposed to be, and now I can fit the images. It's quite fast, say. And what I get here is a background, second component lifetime, first component lifetime, chi-square pixel, the fraction of the second component, the amplitude. And here is the amplitude of the first component. I can adjust the representation of each of them. So if I just leave that to be stretched, not to the min and max, we can have them. And later on, the good thing about using the plugins in Fiji is that these data, these windows which are open for Fiji, they are images. So you can do several things for them with them. So one of the things that you can do, you can use these ones, for example, for segmentation. So the last few days we talked about for the results that we were getting from FLIM to separate different components using phasor plots or doing some kind of analysis with the fitting and so on, or like the NADH images that we said that we have acquired from the salivary gland cells that we needed to segment out or discard the nuclei from the images. So when we are analyzing them in Fiji, we don't need to convert, we don't need to move the data, so to go somewhere else and sitting, doing the conversion to the TIFF, making them images, and so on and so on and so on, to be just ready to come to, for example, Fiji, to do the analysis, and then doing some threshold analysis, doing a segmentation, and so on. So here, that's everything is ready. If I would like to do some segmentation, either I do that on this kind of intensity image that we have here, or if that would be interesting or more apparent in the FLIM data, you can use the FLIM data for as a basis of the segmentation, and then we find out the region of interest after the segmentation. So we just define where we would like to do the measurements, and then we go back on the actual data that we want to do the measurement. So this is a good thing about using these plugins. So I'm just open for the questions regarding SLIM curve. Otherwise, I would move to the other plugin. Marcus also said, is this binning of the lifetime the same as the wavelet filter in the LASX phaser? Ooh, That's a tough question. I don't know that, so I can't really answer this question. I would ask if somebody have more experience and knowledge in this matter, maybe just come in. Mariano, are you there?
We opened the mic, but we also lost.
Yeah, okay. I will say it's not that I'm not lost. It's not the same thing, I think, because here binning the lifetimes, I think it's just binning the channels of the histogram. And in the phasor plot, when you're doing the wavelet filtering, you're basically doing a smoothing of the phasor, let's say, dot. Because you need to imagine that the phasor is mostly like a 3D histogram. You're just looking in from top. And you're just applying some filter to it. So it's not the same, I believe. But I might be wrong. It's a question worth asking to the Leica people in this case.
Yeah, so Marcos, we keep this question, and we can ask also that's the developers that are working on both cases, also that we can ask the Leicas, and then so since they're developing also that is LS phaser, so they might have a more satisfying answer and accurate one. Martin Spital said the binning is like a rolling average, actually a rolling sum. For example, a 3x3 mask. Yes, that's true. So here we are with the SLIM curve. If there is no other question, so just adding very tiny things, otherwise I'm going to close all the windows, is that you can add several files as well and doing the fitting, so you can do that global or one by one. Okay, so I'm just going to close it. And yeah, ignore the log here. And we go now to the FLIM-J, so which is the new generation of SLIM curve. I think that's, yeah, I can call it like that. So for that, just go to the FLIM-J. So searching for that. So that is in the analyzed lifetime FLIM-J, and just run it, and ta-da, there is the first point regarding FLIM-J in comparison to SLIM curve. You need to open your data first in Fiji and then running the plugin. That would be amazing if it would be like a SLIM curve, and when you are going to run it, it asks you which data you want to analyze. So soon we will see that what is the problem with that. Okay, let's go with this test 2, which is that, as I said, the test image that you can find it on the FLIM-J repository. So I just open it, and what we see here when we open an SDD file. So this is actual TCSPC data that we have saved, not me, but it has been saved by the person who acquired it, and unfortunately I didn't find any information about it, what kind of cell line it is, what actually we are measuring, so what are these changes in the lifetime. It would be interesting to know what is more information about this file, which is available on the repository. And yeah, anyhow, so when I open it, so that seems like a time lapse, which yeah, so sometimes intensity is there is a point that intensity is increasing and then decreasing again. So what is this one? Let me just go to the image and adjust the brightness. Oopsie. Low. Okay. Now for a second that the remote connection to the image processing desktop was not happy. So brightness, and then I just say auto, no apply. So I don't click ever apply here. I don't want to change the intensity distribution on my actual image. Now it seems that there is like an intensity, not much of that. We have a few questions. I would just come back to them. So Daniel and Hela. So The thing is that this is like a time. Okay, let me do something. I have an idea. So I just draw a region of interest, and then I say, let's profile the z-axis. I know it seems like in contradiction, but it does what we want it to. And when I say, aha, so what we are seeing here, it's like we are seeing all the information that we have, all the frames that we have here, they are representing the data points on the decay curve that we are acquiring. So when I do plot it across it, here it's shown as time. When I just plot it across the time, what I get is the decay curve. So that's the same story for a single pixel as well. But since the intensity is low, if I do that, it's super noisy. So that's why it would be more visible when I just do that in the region of interest. So what we have here then, it's like TCSPC data. So this is like images of lifetime with lifetime information. This is what we would like to analyze. So now I have this image open. I can click searching for FLIM-J and running that. So when I run it, it's asking me two questions. So the lifetime axis, there are three axes here, X, Y. So X, Y is actually there's special information in this image data that I open. And the lifetime axis is actually the Z, so or the time here, which has 256 samples. And saying that the time being, so it's 12.5 nanoseconds. And just open it, which was, oh no, the time being actually, I did it wrong. It's not 12.5. So it was another value. See that here, seems that it's going to something like some weird numbers, few hundred nanoseconds or so. I'm just shortly calculating that. So it's 256. The channels, that's the histogram depth that we have, and we are acquiring 12.5 nanosecond. That's our data. 12.5 and divided by 256. 12.5 divided by 256. So that would be 0.049. So I need to go back. I'm not sure that if it was possible to actually change this information that inside the software. So that's how I know to do that, 0.48 or 49. And just say, okay. Oh, doesn't seem happy. Okay. Show as the intensity, what I am doing wrong here. Because this one has not really turned to be fine. What was the problem? Everything is just weird here, because I would prefer to see the decay curve, but the scale of X is not correct.
So at the bottom it says start 0, end 0. Maybe if you put end to something else.
Yeah, so that's the adjustment in the beginning, the time that I have.
If you would use end 10 maybe?
It doesn't change.
Oh, it doesn't.
No, it stays at 0. So that's the very beginning. That's why loading the data. That should be correct, actually, what I have done with that. because that's usually asking you in the beginning. And the point here is that when you go to the how does that look? That's documentation of the FLIM-J. It is suggesting that you, when you're asked about this question, when you're loading your data, so in the FLIM-J, it's going to ask you input time base in nanosecond. And showing that 12.5, that's what I did, but the numbers in my x-axis for the decay was looking weird. Let's do that another time. That's the time been in nanosecond. So what I have done, so we have 256 bins. That's the depth of our histogram. And that's the length of 12.5 nanosecond. And I have done the division, and the time being in nanosecond should be 0.048. So that's what I think. And it's, let me go to web page and see that section I can show you. So that is a question to the developer. That's what we have to do here. So I have this question now. So it's saying that when you are opening the data sets, it's accepting 3 or 2-dimensional. And the input database is one of the information which is supposed to be asked. And that shows the whole range, so 12.5, but clearly this value here, it's not 12.5, you just added 12.5. So here, this value starts from 400, ending at 2,330, and that's nonsense. So that's, I can see finally the decay curve, but these values are not correct. And that's why I just closed it again. Maybe that there is something between point and comma. 0.05. Maybe that's why I was using so many digits. No, still. What can I do? Do you have any suggestion? Anybody has any suggestion?
Just one, no suggestion, but what I noticed is when you entered the 12.5, it was automatically back jumping to 10 and not really keeping the 12.5. So I don't know what that means. So
yeah, so I did a test. Yesterday as well, I actually looked at this data and I was able to see that. Interesting. So this is another point about open source software. So they are developing constantly, and there might be bugs still there. So I just go back to the chat and see some of the discussion.
What I would usually do in that situation would be to restart the program, because maybe you did something before that messed it up, and then I don't know.
Exactly, that might be working. So I'm just closing that, and yes. Yeah, sometimes also that specifically since Fiji itself is open source and it's developed and you receive always updates and so on, that might be also causing such kind of problems. Usually it's not the case, usually. So it's not that whenever you get an update, there is a problem. But sometimes there is one specific line in the plugin that you're using, and that might be contradicting for one of the new updates or so on. But I don't think that's really the case. Here is mainly that's the value that I'm entering as a time being seems it's not accepted by FLIM-J. So Fiji is a love or hate relationship. Yeah, that's actually correct. So, and there was any question missing? Was I missing any question here? Is it because end is set to 0? Liat's saying that, yeah, actually the problem is that it's 0 to 0. And clearly it's not doing what I'm expecting it to do. So the time being of the data that's is there, it seems like the value that I was entering, but it wasn't happy with the value I was adding there. Anyhow, so let's try it again. Opening the data. And then I just go directly to FLIM-J. Okay, so many warnings. So let it be. Let's put it at. See, that's the point. Here, that's seems that it is reading the default, the point and or comma or also date. That's this plugin is reading that's from the default of your system, and default of my PC is assuming the comma as the digit. I think that's a German way for the digits, and I was entering 0.01 or 0.5, not 0.05. So now if I add 5 here with the comma, it should be fine. Yes, so this is 12.5. It's now ending, and that's what I'm expecting. And choosing 1 pixel so we can see the decay. Ooh, yeah, so that was the problem of the comma or point. This is usually what we get with many softwares, many cases. Yes, Thomas is also right that sometimes that with different versions of Fiji, we get errors. So we need to check that which version also we are using. And yeah, here we are. So here is the image on the left side. That's we see what we see is intensity image. Then the analyzed image would be on the right side. So I can just say that now show the intensity one as a composite. And I think it is that visible is kind of like blue-green image. And below that, what we see is a decay curve and the residual of the initial fits, and the visualization or the fit of the fits is starting from the second nanosecond, and it ends at 11.65 nanoseconds. So like there is 105 counts in this pixel. On the right side, anyhow, so we have the control on the adjustment of the parameters that when we want to do the fitting. What is here is nice about this plugin is that it is the user interface seems more user friendly, and the parameter that we have, they seem also that's more accessible for less familiar person to FLIM analysis, and seems like very nicely put together the user interface. I'm not sure really what's in the behind of that in the algorithm, what is improved. I didn't go through these details, and we can say that. So this is now the not really a session also that to discuss really in depth what is going on behind this user interface, but this user interface is a lot more friendlier. So it's much more friendly than Slim Curve. This is for sure. Okay, the first one is intensity thresholds. Again, that's I would like to find out where is the background. And when I go with the mouse hovering over the pixels, I don't see any information here, but I can see that on the the plugin itself. So just hovering here, yeah, something about 20, 25 would be. So I just apply 20 as a threshold as well. Exactly, that's how I did it for the Slim Curve. And the kernel size is exactly like the smoothing on the lifetime data. That's what we had before. And we can increase it to 1, and 1 is equal. So what? Oh, sorry. No, here the kernel size is actual pixel binning. That's we see that's when I apply the 1, it's binning the images, and you see that the images get smoother and also a little bit blurry, and that's because that's of the binning that it's doing. So just to be sure that this is exactly what is happening on the kernel. Yes, so it's just binning the pixels together. We can bin all pixels, but not really necessary with this data. And the other one is the algorithm. So we have the global and Bayesian, as well as what we have is so-called this LMA. So we have seen it several times. So maybe I can say that what that stands for is Levenberg Marquardt algorithm. So quite difficult names, but this is the one which has been, I think, everybody or most of the software is using this algorithm for this iterative fitting that we need to do to find the data. And in the noise model, we talk about them. So we go for the MLE as before. The instrument response function, you can add from the file, or you can keep it as none. We keep it as none. And two component. Then we get the different parameters here. So the amplitude, that's the background, and either that we fix them or we fit them. The amplitude fraction, and the lifetime of the component of the first component, as well as for the second one, and the chi-square, which is just an indicator how the fit is working. So you just say that fits database. It should start fitting. And it is doing the fitting. So see that how long that takes to do the fitting. It seems that it's still busy. Yeah, it was showing something. Okay, that was nice. So popping up, saying, yeah, done. And here I can choose which value I would like to see. So mean lifetime, that might be the one that I would like to see. And there are three options. So I can say that as a gray scale. So these are the information that we have for all the conditions that we have applied per pixel. So there's our information, and so the grayscale seems like a binary image. I'm not sure why I see that like that. Or the color image, that might be in the intensity represented, or the grayscale representation. There is like a rounding for the data, because it seems like black and white. Yeah, so that can be addressed to the developers as well. And the color would be showing the lifetime lookup table, color lookup table. Okay, I will see that later. So with the question, and what is we are familiar with, that is a composite color, so which is using the intensity images. So for like spatial resolution as well, and also that's highlighting that where we have higher intensity overlaid with the lookup table, which is coming out from the mean lifetime changes that's across the field of view. And yeah, so when we go on any pixel, hovering that, we can just find out what is the value for that. So the residual, that looks okay. We can check with different pixels, different positions, and maybe these dark ones. They're quite okay. So this default, that's how they're doing that, seems okay. Just one thing that I'm wondering, that's this one here. It's very interesting phenomena that's happening. When I'm trying to fit this value, the fitted curve actually goes to the minus value. So it's like -2 or -3. These I have no idea what does that mean. And also that's here in the lifetime. So very reddish lifetimes, they are something like minus values somewhere. So this is also very interesting point to see that's why this is happening. Is that actually but this is how the algorithm is implemented, and why we get minus values here. It doesn't make sense, because that's here what we have is a count per time being, and that cannot be minus. So that's what is clear. Anyhow, so the last parts in this user interface is that what we would like to export. So I can say that I would like to export the mean lifetime, the fraction of the second amplitude and the first amplitude with lookup table. And you also can save the configurations that we have here, and then we export them. And will look amazing, but the good thing again, as I said that for the slim curve as well, is that we can use this data if later on we would like to do any further analysis like segmentation, measurements, and finding out so where are the nuclei, where are the cytoplasm, and if we have time lapses or time points measurement for different kind of experiment, like studying the drug, the effects that of the drugs on your cells or different components on your cells, or if you would like to see that. So also that's possible. So we have talked about the calcium imaging using FLIM. We have talked about the autofluorescence imaging using the FLIM, addressing the cellular metabolism or the functionality of different samples that we had. We have talked about the finding out, so using the FLIM for the clinical diagnosis, and also that's addressing the biochemical questions, as well as it would be interesting for the people that they are studying, for example, stress granules, so they have different lifetimes typically, or lipid formations inside the different conditions that we have for the tissues, for the inside the animal model and the cells and so on. So these are all parameters that we might need to analyze the data in another level. So it's not only to find out the lifetime or mean lifetime or the fraction of the component, is that how they are changing over time. And another thing is that on each compartment, if you are looking at the cells, for instance, are we the data that we are looking at, or this protein that we are looking at, or these changes that we see for special cofactors or coenzymes and other biomolecules that inside the cell, how they are behaving, if they are in, for example, nuclei, or if they are in the cytosol, or if they have kind of colocalization. We can also do colocalization between intensity and lifetime data that we have. This is what also Amasi, Priyasami, and Holzwa have. And also that's the team they have presented, and they have done some kind of segmentation to find out the mitochondria, and then addressing the NADH and metabolism changes in the mitochondria and so on. So what I'm saying that these tools in Fiji, in combination with all other plugins and possibilities that Fiji is offering, it would be very handy if you want to do second level and third level of analysis with your data, not only exporting lifetime in your field of view or specific changes on the fractions in your field of view or in your samples, but you want to do measurements correlating the lifetime with the intensity changes, or correlating the lifetime with different compartments in your sample and so on. So that was it, kind of demonstration.
There was one question. Could you
yes,
apply your analysis to a specific region of interest in the image?
Good question. Let's apply some region of interest. Seems not. Inside this one, no. It seems no. I cannot draw a region of interest. So maybe that's another kind of region of interest I can do. No.
So you would have to.
But what? Pardon?
So what you could work with is you manipulate the image before you do the analysis, like cutting out areas.
Yes, I think that's that might be necessary.
Yeah.
Exactly. So that might be necessary to do. I don't see that if there would be any possibility to do that. So no, I don't see any option for choosing the region of interest inside. And also that's if I activate that in Fiji, it's not really responding here. But I'm sure that the Fiji developers, they know how to activate that. It should be quite easy to, when you choose something here, that the user choosing something here, that actually they would be activated in this user interface for FLIMJ as well, or not. Okay, so let's go for the questions. I just bring up the questions here. And so Valentin said that, yeah, so that's the answer to Valentin. And then how did the intensity threshold jump from 2025 to 180? Ah, this one you mean? Because I changed the kernel. So it was 0, and I have chosen the 20 for the analysis for the threshold. And when I went to 1, actually, that's a good question. It gives me thrice my eyebrows. So the thing is that when I went for the kernel 1, I was expecting that here I'm doing actual binning on the pixels. But the changes in the intensity threshold from 20 to 180 by changing the kernel from 0 to 1, it is similar to the 3x3 lifetime kernel, so 3x3 Becker and Hickel binning, which is done on the lifetime. That would be interesting. So I can show you, I will show you later on. That's where we address these questions, and some of them that they have not answered, and I don't know the answer of some of them. I just post them, or we can just post them simply that on this image.sc platform. And some of the developers of this FLIMJ, so this plugin, they are the pioneers and very active developers of different plugins in Fiji and Fiji itself. So, and then Marianne is saying that's explaining something. Stella said maybe fuse Roy before starting FLIMJ. Yeah, that's what also Stefan mentioned. That might be something that we can do. So we do the region of interest before that's coming to the FLIMJ. I can crop the image, and so then I'm having a new image and just going to doing all the analysis on that new image. Yes, that's a way to do that. And so okay, that was one thing. Let's minimize this data, close this data. So in the beginning, I said that there is an issue with FLIMJ, one of them. So the issue that I mentioned is that FLIMJ doesn't have this pop-up window to asking me to import my STD data for me. And this is importer of the STD file is not implemented in this user interface. So here is one of the data that I have. So I cannot explain much about the sample because the work is not published yet. But what we are looking here and we are expecting to see is the thread between M turquoise and M Venus. So let's open it. The bioformat importer actually reads the STD file and just say, okay, say that there are 2 series of images, because on our system we have not the Leica system that we explained yesterday. We have another FLIM system, which is a Becker and Hickel system on a Zeiss confocal microscope. So there we have 2 detectors and 2 single photon counting modules. So it's saying that which one of these 2 series you would like to import. And if I don't know which one, so I just say, yeah, okay, both of them. Both of them. And okay. So let's see that how long that takes to open this file. So what we are opening now are 2 images, each of them 2 channels. The spatial resolution, the size of the frame is 256 by 250, so they're not really huge images. And 256 time points. That's the bit depth of the lifetime. That's the decay histogram. It seems not really responding. Oh, not happy. Okay, plug in bioformat importer, then importing this guy, and yeah, simply as default, select all. Okay. And the point also that I have to say that the PC that I'm working on, that it's one of our image processing systems. So it's not a normal laptop. It's not a normal even office PC. It's a computer. It's a system that we are using that's on a daily basis in the facility to analyze data. And this is how long it takes to load one of the SCD files that we have. So that's very, very important to implement this one, because I can open the same data when I'm using a SLIM curve and it's super fast. So we can look at it. How does that work as well? If you have question that how that would be, I don't think that's simply just opening that's like this one. So it's opening every frame like in a second. So that's quite slow. And yeah, I think there are ways to make it a lot faster, at least having like a preview before we are going to open the actual whole SCD file to find out which one we would like to see. Kind of preview, and then we choose out of these 1, 2, 3, 4 images that they might be included in our SCD file or any other FLIM data. Then opening that single one for the analysis would be super helpful. Another thing about the FLIMJ is that it reads only the files with the SDDT extension. I'm not aware of any development in that case. I have already asked them for like PTU or PT3. I was yeah, so I think that's PTU. So PicoQuant extensions, or LaVision, or even Leica extensions. So all of them, and these can be a kind of side project for whoever is interested in that. All the information that you need for developing these parts or adding these parts, they are already available on their repository, which is here. So you can find all the information, all the ops, and also that's codes and how they have developed it, and how you can actually develop something new or add to that. Or at least this is my impression. So in the README, there are some of the informations that we have. So it was where we were here. And there is also one thing else that I have seen it today. I'm not sure if it was there and I didn't pay attention, or it's been added just newly. Was, I think they had a Jupyter notebook that's walking you through the analysis step by step. I can't find it where it was or where I have seen it. But if I'm not wrong, there is a Jupyter notebook that's as well, that's you can use it. It's step by step explaining you that's how the analysis is working and so on. Okay, is there any question? It's opening still, so. Are there any questions? Where is my chat? Okay. Seems no question. Okay, should I cancel it? taking a lot of time to open this data. It's actually, I have not done anything with the FLIM analysis yet. I'm just trying to open my data, and that's it.
Do you know what it's actually doing? I mean, the file itself is not that big. It's just 65 megabytes. So
yeah, so it's actually reading every single image. Just try to open this two-channel like a time lapse.
Is it
two
doing
images.
with processor or I mean, what?
Yeah, with the processor it can be a little bit faster, but that's the case. So it's not a huge data. But what we see here is, I think that's this SDT file. So this Becker and Hinkel data file, they are like zipped or compressed data. But when we open them on Fiji, so it's going to read all the information. I don't think so. It's we are talking about 2 channels, 2 series, 2 channels. That's multiplied would be 4, and each of them having 512, 256. So we are talking about something like 1,024 images, each of them 256 by 256 pixels. So at the end, it's not small data sets. It's opening like 1,000 images. But in principle, that should not be super difficult to open. And so if it could do that directly on FLIM-J, it could be really fast.
So I assume it has something to do with all the timing information when the photons that arrive, etc., which is probably difficult to understand somehow for Fiji, because with a normal data set, it wouldn't take that long. If it were just confocal data, we would have been done by long. Ah, there is some.
Yeah, so here I have the actual software which we can load this data with. That takes seconds.
Yeah.
And one more thing that's regarding FLIM-J, it's very user friendly, and I really like the user interface and how it's working. It's quite fast as well, and the IRF estimation is working really nicely. And whenever you have your data, you export it, so you can use, for example, different tools like trainable vehicle segmentation. So to apply to train a model for segmenting anything in your sample, and then using those information, as I said several times, for your further analysis. Also, that's if you have very large data and a lot of data, and so complicated analysis, you can use, as you see that here, we have, I also that have the CLIGA, which is like a GPU-based analysis in Fiji. It's also always that there are updates in this package for the GPU analysis on GPU as well. So it can do so many things. That's the whole point that I'm repeating. That's using Fiji plugins for FLIM analysis. Okay, let's close it. So these are my images. And close this one as well. Here they are. So that's one of them. 4. There are 4 actually. And I just need to go somewhere to find my sample. It's exactly the same thing. So I just go for adjusting that brightness, and here it is. So let's see what are the names of them, and exactly this is what I would like to analyze. So what I have to do again, I should close this one. I don't see any way that I can somehow click and load this image without closing FLIM-J. So I just go to FLIM-J, see that how does that behave with this 2-channel image. Hello. Okay, analyze lifetime. And here was 5. So it's actually read only the active channel that I have, not both of them. I don't see my second channel. And if I choose this one, so it's now automatically adjusting the heights in the Y, and it looks quite okay. And what I can do, I can apply some thresholds. So here, for instance, is about 1,300. So 1,300. Oopsie. 500. That's still a lot. No, that was 130. So I would just put it at 200. I would like to get some information. Nothing. 0. And here was that. No. I would like to do this before. Yes. It's 130, 150 inside the nuclei. So I'm not expecting to see any signal in the nuclei. So to subtract the nuclei contribution to my FLIM analysis, I put the threshold in a way that the nuclei are almost discarded. That would be 200. Still was a good one, 200. And the kernel size, I can change it or not. So I can change it for having really reliable FLIM analysis. The algorithm, which stands on the environment marker algorithm, and the noise MLE, 2 components. That's what we are expecting. And I can fix one of the components. For example, that the second lifetime for unquenched M-tone turquoise in our sample is about 3.5 nanosecond. So now here it wants me to like that. No. Okay. Why? Okay. I don't know. So let it fit it. It doesn't. It doesn't accept to fix this value. Just go jumps back to 0. Okay, let's fit the data. That might be a bug. So another thing I would like usually to have is that to have an indication that's like a bar that telling me that how the process is going on. But seems that the fitting didn't work well. So I don't see any fitting. Oh no, here, that's the position I saw that. Okay, now I can look at the mean lifetime, for instance, the composite way, and for the exports. They see that it's working quite nice, and also the value that I'm finding out, they are quite different. But I was expecting to see the tau one about 3.5 nanosecond, but now it is fitting. This plugin is telling me the long lifetime of my donor. This means that unquenched donor is actually 4 nanosecond. So I have to come back to that and check it. That's why it is like this. Good. That's been a kind of demonstration. I hope that I could introduce you these 2 possibilities. Well, that's just making you interested in paying attention to this open source offers and then investing some time on them. Maybe that's keeping proper and continuous communication with the developers and discussing with them what you need, what if there would be any bug and so on. And this one, that's I can just show you that if we go to the image.sc, oopsie, image.sc, so you see that there are already discussions about FLIM-J and SLIM curve going on. So I can simply just add any topic. So searching for example, FLIM feet. And here is one discussion. So I would suggest that let us as a community that's who are interested in doing FLIM and also that's analyzing this kind of data with open source softwares or none. So it's not really related to this forum is not really related to only the people that's working on the open source software. So whatever question you have related to the images in bioimages or different kind of questions you have about images using Fiji, using commercial, non-commercial softwares, if you're a developer or if you're a normal user or just a newbie, for example, like me in many of the topics there, I just ask if search, if I don't find what I'm searching for example, when I'm writing a macro, I don't know how to do something. Just go there, Googling that or checking that's in the search bar of image. So this forum, so I just search whatever I want. If there would be the answer that I need, that's perfect. If not, I can just open it and typically my personal experience say that I get the answer in latest a day or two. Okay, let's go back to the questions. I just stopped sharing. That was all. And let's see, where is the chat? So we have something in the chat. Okay. Perfect. Thank you, Daniel. Yeah. So there is a link to the Jupyter notebook that's Daniel Weiger has shared it. So I would suggest that you go through that and look at it. So it's a nice way to showcase how the softwares or the plugins are working. Do we have any other questions? Okay, then if not, thank you very much for being with us. And yeah, soon we will see each other again, I think, or many of you for the next workshop.